Okay, let's take a look at the circle geometry problem, and we are trying to find, well, I guess we should read all this carefully too. We should. These two sides are exactly the same. I think they told us that. They tell us the angle down here, DBC, is 22.5 degrees. They tell us that this is the center of the circle. They tell us O is the center, and they tell us, I think, that D and B and A are points on the circle, and CB is a tangent. That's important. And there's a triangle in the circle, and that's going to get us our first thing, A1. That's the angle between the tangent and the chord, and there's the angle in the alternate segment. A1's got to be 22.5 degrees. Tan chord theorem. There you go. Okay, what about figuring out D1? Well, I don't know. I can't see that there. What if we found C first? Because of angles opposite equal sides, then these two angles have to add up to the exterior angle. In fact, that's what D1 must be. It must be 45 degrees because 22.5, that's 22.5. Angles opposite equal sides. D1 is 45 degrees. The exterior angle of this triangle, DCP, there you go. Okay, that's 45 degrees. Now we're going to try and find B2. And I'm looking, I'm thinking, this was a tangent, and this is a radius. And isn't the tangent perpendicular to the radius? That means that this 22.5 and this B2 must add up to 90 degrees. Well, that makes B2 is going to have to be, because OBC is at 90 degrees, the tangent's perpendicular to the radius, B2 must be 67.5 to make this 90. Well, there we go. We got that's 90. Now, this angle O1, it's an angle at the center. And D1 is an angle at the circumference. And we know the story there. The angle at the center is twice as big. We knew that was 67.5. This is twice as big as 45. It should be 90. The angle at the center, 2 times the angle at the circumference. And that's why O1 is equal to 90 degrees. And that's your answer. And that's your reasons. And there you go.